if we go for the next one, so linear motion, Newton's second law of motion, I would like to start with that. So this was the Newton's first law, discussed, then Newton's second law. Once again, starting with the law. Now we have not calculated earlier about the force. We have only talked about the force. Now the value of force, what should be? The acceleration of a body is a parallel and directly proportional to the net force acting on the body. And it is inversely proportional to the mass of the body. So if we get the idea of the amount of force, to calculate quantity of force also, we can get it from here. So quantity of force will be derived from the Newton's second law of motion. This now, in the Newton's second law of motion, again with the pictures, if we go for the idea, a force is applied on the body, you may get an acceleration. If you increase the force, you may get more acceleration. If you apply the force less, you will get certainly less acceleration. This is the idea. But when? I would like to test with this, first with some experiment. Look at the experiment. We have taken one object with a mass small m, applying a force F, getting an acceleration A. If we have the uniform mass of two bodies, applying the same force F, getting reduced acceleration. Having three same mass body, applying the same force F, getting still reduced acceleration. Similarly, another set of experiment we have already made, we can also do it. Another body having capital M mass, applying a force. Then another thing, it is capital M, the same body, force is more, getting acceleration more. Then the body is the same, and we are applying more force and getting more acceleration. Now we would like to know from you, from the first set of experiment, three parameters are there: force, mass, and acceleration. From this experiment, you have to say the mathematical relationship between the parameters. You should not say F equal to ma, but because we are not getting here from that expression. From memory, you should not say. From the first experiment only, you have to say what is the mathematical relationship between the parameters shown here. First, times from the experiment, you have to do it. So A inversely proportional with mass when F is constant, and acceleration is directly proportional with force when mass is constant. From here, taking together, you can make one relationship, what is known as F equal to ma, when everything is taken as unit, and then the constant of this equation will be also unit and can have this type of equation. From one experiment, we can get this type of idea. I would also like to have one experiment to verify Newton's second law. I would like to start with that. Please check this one. Newton's second law, I would like to verify this one. We are having several things here: trolley, some smooth with wheels and weights, timer, and a twine or a thread, and also pen and some mass also. So these are the things we would like to start with the experiment. So here the experiment is like this. A trolley is tied with the pen here over a wheel. Some weights are kept on the trolley. So certainly trolley is not moving. Now how to move it? If we keep some weights here on this other side of the pan, but still the trolley is not moving. If we put more weight on the pan, check the trolley is moving now. So we can record it with the timer also, what is the time taken, distance traveled. And if we put more weight on the pan here, and we can find that whether the trolley is moving if we add more weight on the right side in the pant. So by this way, we can record the distance traveled by the trolley and the time taken. In this way, we can complete the table, and in the table, we can find that this here, F by A is always constant. Force by acceleration is always constant here. So this shows our second law of motion, which is represented by Newton, is okay. It is justified. So from experiments also you can come to conclusion that Newton's second law can be justified or can be taken as a proof for all this what he has said. So force and acceleration are vector quantities, and speed increases. If it is anti-parallel, parallel, you have to go for that, and if it is perpendicular, how the direction changes or whether it is decreases or whether it is increases, you have to justify it accordingly. So relation between force and speed, just to only to remember, I need not to write. I think from here you can understand it. Simple ideas to go get it. Now one thing, Newton's laws of motion, question is given. Can we derive first law from second law? Salt Lake 9A. That is Newton's first law from second law. We derive first law from the second law. This was the case. So layman's question we were asking, can we abolish the first law if we can derive the first law from the second law? The thing was this: if we can derive the first law from the second law, so can we abolish the first law, because the first law is the corollary of the second law? Or in another term, we can say, is there any necessity to keep three laws now? Because sometimes you will also find that third law can be also be derived from second law. So what's your response? So the question is here, I would just to go for that. Newton's laws of motion. So first, I would like to mention one story. Sometimes stories are very important in our class. We do not get stories much in time because we are busy with the content. So there is a story you can think that a thief is running away with the stolen thing. So the police officer saw that and he asked the subordinate, the police, then to catch the thief. So thief is running in a uniform velocities, and the police, that constable, he also started running. So he is also running in a uniform velocity. The Usain Bolt, the fastest runner on earth nowadays, at getting the gold medal in the Olympics and many other places. So he was also having his training a little far away. So police officers saw him, also asked him to catch the thief. So he also started running to catch the thief. After a few minutes, the police officer is saying that thief is going away from me. The police constable, he is saying the thief is always keeping away the same distance ahead of me. And Usain Bolt is asking the police officer, sir, how can I catch the thief? He is always going far and far away from me behind. Because Usain Bolt is in acceleration, he is going very fast, and thief is always behind and still more behind. So from this story, we can see that for this event, police officer is saying one thing about thief. The police constable is saying another thing about the same thief, and Usain Bolt is also saying another thing about the same thief. So all three persons are saying about the thief differently. Why? One is saying going away from me, another is saying keeping same distance ahead of me, another is saying he is going behind me. So because everybody having three different inertial reference frame. From point of his position, he is saying, because police officer is sitting, from his position he is saying, the police constable is running in the uniform velocity, from his position he is saying, and Usain Bolt in acceleration he is saying from his own position. So this is known as inertial reference frame. All three are different. The concept of inertial reference we get from the first law of Newton. When Newton say body at rest means against an inertial reference frame. When Newton is saying body at motion in a straight line in a uniform motion, uniform speed, then he is referring to an inertial reference frame. So the concept of inertial reference frame is coming only from the first law of motion. You cannot get it from second law of motion. So I will write these things. It will help you to understand. So we get concept of inertial reference frame, concept of inertia, and a definition of force. We discussed about the definition of force and also about the inertia earlier. So these things we can get from first law of motion. In the second law of motion, we calculate the amount of force required to change the momentum or change the motion, etc. So we can get that thing in second law. We cannot get the inertial reference frame concept from the second law. So that's why first law should be there. Second law should be there. We can say that there is a very close relationship between first law and second law. But first law cannot be derived fully from second law. So Newton's first law and then inertial reference frame, what does it mean actually? You may forget, so I will also give you an idea about the inertial reference frame. So an inertial reference frame is one in which motion of a particle not subject to a force or many forces with a constant speed in a straight line, it is going on. So this is your inertial reference frame. So this is the thing that you have to consider when you are talking about different laws of motion. So inertial reference frame, inertia, and force. Mind it. There are several other things. I will also mention at least two things or maybe three. These are also hidden in Newton's laws. So these are, now another things are also there, or rather three things are there. One is mass is assumed constant in these laws. There is not mentioned about the mass. We do not know that whether mass will be increased or decreased in this motion. There is a possibility. Suppose if you...
Excuse me, Swamiji.
So mass can be increased. Suppose if you roll a ball with in a wet condition on a sand, then ball will collect sand on its surface and the mass will be increased. We do not say like this. When you applying Newton's law, then mass cannot be increased. Suppose if you are launching the rocket, at that time fuel is burning, so rocket is losing mass. We will not consider the losing mass of the rocket. So mass may be decreased or increased. We are not considering that. We will consider mass as a constant in this law. Nothing to do it. So another two things actually there. I can say these are the assumptions. So Newtonian mechanics, it is said Newtonian mechanics that absolute space and absolute change. And actually on this place, Einstein came in and he proposed new ideas. And there, the space and time will be changed and there is a curvature of space and time. So here is one aircraft. what are the forces acting on it when it is flying? What are
Gravitational
the...
force.
Yes, go on. Here, when an aircraft is flying, we can find four types of forces are acting on it.